So next is question number 1.3.177. In this question, a circuit is given that comprises of one cell in series with a resistance, then there is another cell and it is connected across the capacitor in series with the capacitor, and there is one more cell, third one, which is connected with a resistance. Okay, and the EMFs are given that this EMF is E1, this one is E1, and lower one is E2, and E1 is equals to 1 volt, E2 is equals to 2.5 volt, one resistance is R1, R1 is equals to 10 ohm, and R2 is equals to 20 ohm. The internal resistance of sources are negligible. We have to find out the potential difference phi A minus phi V, which is across this capacitor. Terminals are A and B. Okay, so now we have to find out the potential difference between these two. And I think polarity of cells are different. Here I marked the wrong direction. These are like this: positive terminal and negative terminal. Now see, please look at carefully. At steady state, when this capacitor will get fully charged, so it will block the further flow of current, right? So this portion will act as an open circuit. So we can write that at steady state means when capacitor is fully charged, then capacitor blocks flow of current. Okay, it means there will be no current in this circuit. So the total current I will pass through this external circuit, the current I. Okay, so if you go by the KVL in outer loop, here I am writing KVL in outer loop from this end, 1, 2, 3, 4. 1, 2, 3, 4. So from here we'll get E2 minus E1, the potential difference, is equals to I times R1 plus R2. So from here we'll get current passing through this circuit is equals to E2 minus E1 over R1 plus R2. This is our first equation. Now as we are interested to find out voltage between these two terminals, so let's apply a KVL in this inner circuit. That 1, 2, and let me write 6, 7. Okay, so that you can correlate. Loop number 2. So again we'll write KVL in loop number 2. So this KVL will give us E2 minus E1. I am assuming this potential is higher than this one is lower. So minus VAB, the potential difference between terminal A and B, and definitely minus I into R2 is equals to 0. So from here we'll get the potential difference across terminal AB is equals to E2 minus E1, one term, minus I into R2. So R2, and we can replace value of I from equation number 1. That is E2 minus E1 upon R1 plus R2. Okay. So if we'll simplify this expression, although we can substitute net value here only, but if we want to simplify, then multiply by R1 plus R2 in this term, and because of that R2 term will get eliminated, and we'll get VAB is equals to R1 into E2 minus E1 over R1 plus R2. So known value of R1 is 10 ohm, E2 is 2.5 and E1 is 1, so E2 minus E1 is 1.5, and this is divided by 30. So 1.5 you can divide this is 15 by 30, 1 by 2. So VAB is 0.5 volts.